Hi guys, in this video we're going to talk about random variables and how to compute their probabilities. A random variable is a function x from the sample space omega to the real numbers. For example, suppose we flip a coin 3 times, so the outcomes could be heads heads heads, or heads heads tails, or heads tails heads, and so on. A random variable on omega might count the number of heads that we flipped. So if x goes from omega to r as the number of heads flipped, then x of hth equals 2 because it has 2 heads. X of ttt would be 0 because there were 0 heads. So a random variable takes in the sample points and gives you back a real number. To continue reviewing our set theory, we're going to talk about the preimage of a function. So if f goes from a to b and c is a subset of the range, then the preimage of c is everything that maps to c. So f inverse of c is a set, and it's the set of all x in the domain such that f of x is an element of c. For example, let A be the set 1, 2, 3, 4, 5, 6, and B equal the set little a, little b, and little c. And f goes from a to b by f of 1 equals a, f of 2 is a, f of 3 is b, f of 4 is a, f of 5 is b, and f of 6 is c. Then, taking the set BC, which is in the range, it's a subset of the set capital B, we can look at the preimage of the set BC under f, and that's everything that maps to B or C. So the preimage of BC is 3, 5, and 6, because 3, 5, and 6 are the elements that f of 3 equals b, f of 5 equals b, and f of 6 equals c. The preimage of A is 1, 2, and 4, so we say f inverse of A equals 1, 2, and 4, since 1, 2, and 4 are the elements that map to A. So now let's revisit the coin flips. We want to compute the probability that we get 2 heads, or in other words, the probability that x equals 2. Remember that probability is a map from the power set of omega to the real numbers, so the probability needs a subset of omega. Well, x equals 2 refers to a subset of omega by taking the preimage of 2 under x. So x inverse of 2 refers to the sample points hht, hth, and thh. So the probability x equals 2 is the probability of the subset of omega hht, hth, and thh, which is 3/8. Similarly, we could compute the probability that x is less than or equal to 1, or in other words, that we have 1 or fewer heads. This would be the probability of the preimage of the set 0, 1, and the preimage of the set 0, 1 is the set of 3 tails, or 1 heads and 2 tails, and that has 4 elements out of the 8 sample points, so the total probability is 1/2. So using a preimage, we can compute the probability that x has a certain value, or lies in a certain range of values. So whenever x goes from omega to r, for any set A in R, x inverse of A is some subset of omega. And P is going to take in subsets of omega and send them to 0, 1. So since x inverse of A is in the power set of omega, it makes sense to define the probability of x inverse of A. For example, the probability that x equals the point little x equals the probability of the preimage of the point x. Or the probability that x is in the interval from a to b is the probability of the preimage of the interval from a to b. The probability that x is less than or equal to, is less than little x is the probability of the preimage from negative infinity to little x, and so on. So that's how we define the probability of a random variable.